under differentiation. We are given this question. This is the function itself. F of x is equals to s cubed, right? Then f prime of x is equals to 3x squared. When we say f prime of x, meaning dy dx, given this function, let's say you are given that y is equals to x cubed. Let's say you are given that y is equals to x cubed. Then the question says that find the derivative, or the question went directly and saying find dy over dx. What we answer be dy over dx is equals to what? 3x squared. But in this case, that question wants us to use, we are differentiating using what? First principle. We are differentiating using what? First principle. Now from here, let's solve. Y, from this question, my f of x is still the same thing as what? Y, right? Now I can write the given question as y equals to what? X cubed. Y equals to what? S cubed. Now before solving, let me say this. From differentiation, giving y is equals to sine s, your derivative becomes what? Cos x. Giving y equals to cos x, your derivative becomes what? Minus sine s. Meaning, given any function generally, you can easily get the what? Derivative, right? But there's how those derivative is being derived by first principle. So to make our work easier, that's why we just have the derivative easily. But some question we want you to show the derivative using first principle. Now, from here, what it means is that given any polynomial question, or you are given any quadratic question, or you are given a monomial question. When we say monomial, meaning you have ax squared, quadratic ax squared plus bx plus c, right? Polynomial ax cubed plus bx squared plus cx plus d. Now you are now saying, given any monomial function, given any quadratic function or polynomial function, this is how we find the derivative using first principle. This is my left hand side, this is my right hand side. Meaning for the left hand side, I change in y, for the right hand side, I change in x. Meaning that y plus change in y is equals to x plus change in x all cube. Take note, if you have x squared, x cubed, x raised to power 4, you want to add change in x to this. This is your answer, x plus change in x. You want to add change in x to this. What's the answer? X plus change in x all squared. Similarly for x cubed, what do you have? X plus change in x all cubed. So that's what we did here. Meaning adding change in y to the left hand side, I have my y plus change in y. For the right hand side, x plus change in x. This is how we write it. Meaning your first task is what? For the left hand side, add change in y. For the right hand side, add change in x. Now take this y to the other side. Meaning that change in y is equals to what? X plus change in x all cubed minus y. Then initially we said y is equals to what? X cubed. Substitute. What do you have? Change in y is equals to x plus change in x all cubed minus what? Change in minus x cubed. Now from here, moving on, what I just need to do is to open up this bracket. I just need to expand this bracket, and this will take us back to binomial expansion. From binomial expansion, you have Pascal triangle, right? It is a Pascal triangle that gives the coefficient of your terms. Now let's say you have this is your Pascal triangle: 1 1 2 1 3 3 1. Then continuously, what do you have? 1 4 6 4 and 1. Let's stop here. This is your Pascal triangle. Also, let's open up this bracket. Let's say you have a plus b all cube, where our a is equals to what? X, and b is equals to what? Change in x. Now let's expand this. From binomial expansion, to expand this, you have, since your power is 3, meaning a is starting from 3 up to what? 0. A is starting from what? 3 up to 0. The next term is what? B. B is starting from what? 0 up to what? 3. So this is what? A raised to the power of 3, right? Plus a raised to the power of what? 2 plus a raised to the power of 2 plus what? A raised to the power of 1 plus a raised to the power of 0. For the next term, B. B is starting from 0 up to what? 3. Meaning B raised to the power of 0, B raised to the power of 1, B raised to the power of 2, and B raised to the power of what? 3. Then from here, what do you have? A raised to the power of 3 plus a raised to the power of 2b plus ab square plus what? B cube. Now, from Pascal triangle, substitute the coefficient. What if the power is 1? This is your coefficient. If the power is 2, this is your coefficient. If the power is 3, this is your coefficient. And if the power is 4, this is your coefficient. Now, in this case, what's my power here? 3, meaning I'm going with this. So, going with this, I can write this as what? A cube plus what? 3a square b plus 3ab square plus b cube. Now, substitute the value of a and b. We said a is equals to x and b is equals to what? Change in x. Now, let's substitute. What do we have? X cube plus 3x square change in x plus 3x change in x all square plus change in x all cube. Now, you've expanded this. Now, substitute. Meaning that change in y is equals to what? S cube plus, please call the values from here. 3s squared change in x plus 3x all into bracket change in x squared plus change in x cube minus what? Minus x cube. Now, up to this level, divide both sides with change in x. Divide both sides with change in x. You dividing both sides with change in x. For the left hand side, I have change in y divided by change in x, right? Or divided by what? Change in x. And from fractions, change in x will affect this term individually, right? So let's do that. Meaning I have all divided by change in x, all divided by change in x, this divided by change in x, this divided by change in x, and this divided by what? Change in x, right? From here, I'm left with what? Change in y over change in x. So this cancel this, right? So I'm left with what? 3x squared plus 3x change in x, right? Plus change in x squared. Now, this was the question initially. The question says that we should use this to show that the function given, which was s cube, is equals to what? 3x squared, meaning the derivative is equals to 3x squared, using the same limit. You observe that from the given question and what we have here, we are almost there. But what we are yet to introduce is what? As change in s tends to 0. As change in s tends to 0. Now, meaning from here, I have as change in s tends to 0. What it means is that wherever you see change in s, substitute what? 0. Substitute 0. Now, meaning I have change in y all over change in x is equals to what? Now, let's do that. That becomes what? 3x squared plus 3x all into bracket 0 plus what? Plus 0 squared, which is equals to what? 3x squared. Meaning we found f prime of x from the question. So what this means is that this is actually first principle. By first principle, you'll be given a function and that function given, you are going to apply first principle. You still get the same answer as using the general method of differentiation. Now, The idea is that for any function given, you can find the derivative using what? First principle. Let's say you are given f of prime, or say y is equals to what? Sine x. You know, from what we know, the derivative is what? Cos x. You can use first principle, you are still going to get this cos x, but this will involve a lot of trigonometry identity. You start recalling your trigonometry identity. But generally, as I've stated earlier, for any monomial function, polynomial function, quadratic function, these steps remain the same. These steps remain the same. But moving on to trigonometry function, it will be different. Though you are still implementing the same idea, but it's just that you recall your trig identity. So that's how it works.